This week in math, we are learning dividing whole numbers by fractions and dividing fractions by whole numbers. In their journals, if we're dividing whole numbers by fractions, we've done this foldable here. So we're doing questions like 6 divided by 1/2 and 3 divided by 1/4. And what the question is asking is how many total halves are there, in this case, 6 wholes. And so we drew 6 holes and we split them all in half, and we can see that there are 12 total halves. But it's not 12 halves because that would be the same as 6. So this is where it gets a little confusing. The same for here. We drew, how many fourths are in the 3 holes, and so we drew the 3 holes, split them into fourths, and we can see that there's 12 total. I like to use some word problems better to help them understand it. Like in this one, if you have 3 Snickers and you split each bar in half, how many pieces do you have now? Well, if these were the 3 Snicker bars, we could see that there would be 6. So if we split 6 bars in half, we would get 6 pieces. And so that's kind of a better way to understand it. We do talk about this, but not till later on in the week. It's just a little hint for them. If it starts with a whole number, then we end with a whole number, and then that takes us to, if you start with a fraction, you end with a fraction. And so like in this one, we're taking 1/2 divided by 3, and that gives us 1/6. And so in this case, we're asking how much of the part does each person get. So I like to use it like with brownies. So if you have half a pan of brownie left and you split that half between 3 people, each person does not get a third. They're getting a third of a half, which is 1/6. And the same here, if we have 1/3 and we're dividing it by 4, how much of the part did each person get? Again, think of it like brownies. If this is, a fourth of a pan of brownies are left, and we're splitting it, a third, sorry y'all, a third of the brownie pan is left and we're splitting it into fourths, each person does not get a fourth. Each person would get a 12th because it would be out of the whole pan. And again, if you start with a fraction, you end with a fraction. And so what really has been more helpful for the kids is we've been using these bars here to kind of help us understand it a little bit better. So for example, one of the problems we did yesterday was this one. So Cass bought 4 yards of ribbon to make hair bows. Each hair bow can be made with 1/3 of a yard of ribbon. How many hair bows can Cass make? So we would use maybe these yellow pieces to each represent those 1 yard each. So each one of these would be 1 yard to represent the 4 yards of fabric that she purchased. And we know that each bow takes a third. And so one of these bars would represent the 1/3 that it takes for 1 bow. And then we would fill it in with all of the different pieces and so forth. So we would take it and we'd keep filling them in. We can see that 3 of them would complete the 1 yard, so we can make 3 bows out of 1 yard. So that means we can make 12 bows because it'd be 3 and then 6, then 9, then 12. And so basically then what we did is we took the 4 and we divided it into thirds, and that gave us 12 bows. So that's kind of a way to look at it a little bit. It helps in context more than anything for that one. Today, the students are going over how to do these in for fractions, and that is where it's a little bit harder. We can see splitting up wholes into fractions and so forth, and we can understand that a little bit better. For example, on this one, Grandpa has half an acre of land he needs mowed. His 3 grandsons equally split the mowing. So, what fraction of an acre did each grandson mow? And so, on this one, we might use this bar right here, and this would represent the half of an acre. And what we need to remember, though, is we want to try to compare it out of the whole yard. And that's where it becomes a little bit different, because this is a half, so this is the other half. We know that this is already done, but we still have to compare it out of the whole. So this is the, 1 acre total, this whole thing. And so if we were to look, if this is one kid, and one kid, then we can see what is tempting is that the students would say, oh, then each kid does a third of the acre. But that's not true, because when we look here, this is of half an acre, so it's not going to be each of these is a third. If we fill these in still, each grandson isn't doing a third of an acre, they're doing a sixth of the acre. Because it would take 6/6 to make the 1 acre, and they're only doing half of the acre. And so that's where it gets a little bit different. So in this case here, we took 1/2 and we split it in 3 ways, and that gives us 1/6 of an acre. And like I said, this is where it gets a little bit more difficult. It's tempting to teach the students reciprocals and for them to, keep, change, flip. And that is very tempting to do. And they will talk more about that in 6th grade. In 5th grade, we don't tend to talk about the keep, change, flip or reciprocals, because we're really wanting them to understand it visually before. So I ask that you don't teach them, just multiply it. They see that very quickly. They're like, well, 2 times 3 is 6. So can I just multiply it? They already see that. And that's the whole point, is to discover it. So, but I don't go over reciprocals with them, not in the 5th grade. They talk more about that in 6th grade. So if you have any questions about this, this isn't a difficult thing. The kids usually get it pretty well, but really the hardest part is, when are we dividing a fraction and when are we dividing a whole number, so we know which model to draw. That truly is the hardest part. So if you have any questions, let me know, and I'd be glad to go more over it with you. So hope you have a great week. Thanks so much.